Huh. Today is October the 16th. It is getting close to Halloween time. This there are two worksheets I'll give you. Um, yeah, well, the first one today isn't that bad. The second one is a lot harder. That one you'll get probably tomorrow. Kind of depends how we do, but you'll get it for sure either tomorrow or Wednesday. So I take these out of a workbook. Have you guys know the worksheets with let me pull up my Canvas for you. Well, I don't know if it has an animal. Let me see. I don't have this published yet because I don't like to publish things until they're ready to actually be considered presentable. So the recording that I'm yapping over right now is going to be on there. But this is the worksheet. You guys have seen these before where they make a joke? Yeah. Okay. Well, we're going to start doing some of these. I don't know how I'm going to approach this. Jesse, turn around. But these are more fun when the jokes get spelled out. But we're going to start today once I'm done with the lesson. You can see there's a lot of letters, right? Yeah. So what I'll have you do today is when you pull this up on Canvas here in about 15 minutes, you'll just copy the problems onto your notebook paper, solve them, and then we'll try to figure out a way to reproduce the puzzle. I really am trying to limit making homework copies this year. So I really want to keep it this way. But these have jokes at the end. So like when I solve equation 1, I'll pick one of the answers that goes with it, the letter, and then I'll put that in the box at the bottom. And it usually, well, to me, it always spells a funny joke. To kids, it's usually not, but I like them. So what's that? What's that? Yeah, they're terrible. They are. They're terrible. Yeah, you're not going to get a rise out of me. They're terrible. So yeah, anyways, this is what your homework will look like tonight. So let's get back to it. Yeah, so I have 9 examples because I went through the assignment that you have to do, and I thought I want to do an example to make sure that ideally every question you see on the homework, you're like, oh, we did one like that in the notes. So they'll be a little intimidating at first. But anyways, you're wondering what is a literal equation? And I already sort of alluded to this earlier. Literal equations are equations that have more than one variable. They're sometimes referred to as formulas, and that really depends on the context. So like you've seen formulas before. I'm trying to kind of stay away from that for today, but a formula is something like if I wanted you to find the circumference of a circle, I would have you use the formula circumference equals pi times diameter. Or if I said, here's the formula to convert Celsius into Fahrenheit, I would give you a formula, right? And formulas have to have more than one variable. There's always at least one input and then one output. So we're going to call them literal equations. We're going to stick with that. But you will see some formulas, but formulas are examples of literal equations, just so you know. So this is our first one here. I'm just going to run through the examples. Hopefully we just go cooking through this. The foundation that you guys have built is the key. This shouldn't catch you too off guard. So every time I give you a literal equation like this, afterwards, I'm going to tell you what I want you to solve it for. So after this, you'll see something like 4m. And what I'm saying to you when I say that, or when anyone says that, is I want you to manipulate this equation so that m is now by itself. And we're not used to this. We're used to like m equals 3/4 or m equals -10 or stuff like that. When you do literal equations, your answers will have letters in them. It's inevitable, right? So follow your mathematical instincts that you have developed. How would you go about getting M to be by himself? You've got to be thinking to yourself, I need to get rid of that number and I need to get rid of that letter, right? You think simply, if I could eliminate those two numbers, then I would be doing what I'm supposed to do. M would be by itself. Woo! How do we get rid of that 2? How do you get rid of the N? Yes. So we're going to divide the whole thing by 2N. Basically, this whole 3 days is going to come down to you can do whatever you want. If you want to multiply both sides by P, multiply them both by P. If you want to subtract an A, subtract an A. I mean, you can do whatever you want as long as you do it the same to both sides of the equal sign. But in this case, I want to divide by 2, and I also want to divide by N, and I can do them both at the same time. So on this right-hand side, the 2's cancel and the N's cancel, and I'm left with my final answer, which again is a tad uncomfortable at first. We're not used to this, but the answer is actually M equals K over 2N. Done. Again, you'll get used to it. With literal equations, you have to have a variable in your actual answer, because if it starts with more than one variable, he's got to go somewhere. So there's an example of a literal equation with 3 variables. I would ask if you have any questions about that, but chances are you're probably like, that was kind of okay. A little weird though, right? They're going to start to get bad in the next lesson. But I don't think anything today is really wicked. I don't think, but you're welcome to just pause me and tell me when I'm wrong, because I'm sometimes not the best judge. For our next equation, we have J equals R x to the third. By the way, I don't think that's a real formula. I was just making them up. So if I asked you to get x by itself, this would be a much harder problem because there's an exponent on the x. So for today's lesson, we're not going to get any exponentiated variables by themselves. Okay, just FYI, that's for the next lesson. So for today, the only thing reasonably that I would ask you to do is to solve this equation for R. And again, every literal equation that I or anyone asks you to do is going to, after it, say solve for this. And that's what we mean. So translation, get R by itself. So who do we want to get rid of? I want to eliminate x cubed. And so I, say again? We actually want to divide because it's clinged on by multiplication currently, you see. And the only way to pull something off as a multiplier is to divide. So we divide both sides by whatever, like I said earlier, whatever you want, you can divide by. As long as you do it the same on both sides. And if I want x cubed to go by, I divide by x cubed, and I'm left with my answer, which is R equals what? Yep, as uncomfortable as that might feel, it is what it is. That is the final answer. 2 down, 7 to go. How are we so far? Mm-hmm. Mm-hmm. Like when you write your final answer, you would rather write it as R equals J over X cubed like that? Absolutely. A lot of times we develop that. Like some of us just feel like, I just don't like it the other way, and that's totally fine. Totally fine. All right, example number 3. Again, a made-up formula. We have M equals 4y's minus lowercase j. And you do, by the way, for you folks who think this kind of stuff doesn't matter, you must respect the uppercase and lowercase. I'm going to say that again. You must respect uppercase versus lowercase. In mathematics, different, like capitalized letters versus non-capitalized letters stand for different things. Lowercase r is the radius of an inner circle. An uppercase r is a radius of an entire circle, like in an annulus problem. Capital A's usually stand for area or angle measures. Little a's stand for usually side lengths. So it does matter, and I'm going to call you on it. So if it's a little j, put a little j. If it's a big J, put a big J, so on and so forth, okay? Save me the red ink and save yourself the hassle of being nagged about it. All right, so we're trying to get y by itself. I didn't tell you that yet, so why would you know? So we're going to solve this literal equation for y. This is where I think it can get a little bit intimidating for some folks. Say it again. You do. And you just know that because you've done so many algebra problems that by now you understand that eventually we do want to kill that 4. But you also have done enough hundreds, if not thousands of equations by now that you know that the 4 is going to be the last one to go. Just like it would in any other situation, 4 can wait his turn. Good job, Alana. So we're going to add j like this to both sides. That's going to eliminate the minus j, bless you, just like we want, and bless you again. And it's going to leave us now, and 3 times, bless you again. So we have 4y drop down on the right-hand side. What is the left side going to say? It is going to say m plus j. You guys who try sometimes to combine things that can't be combined, watch out. M and J cannot go together. They're not like terms. They're not the same variables. So we just leave them as an addition problem. We cannot do anything with them, right? Now, how do we eliminate that 4? Now we divide by 4. So we go back to saying, okay, now it's your turn, 4. I'm going to divide by you, and I'm going to divide like this. Notice I just did one big division sign. In problems like this, that's just fine. So these 4s on the right are going to eliminate each other, leaving us with our final answer of y equals what? M plus j divided by 4. Funky. Still good? 3 down. Okay. Next one. We have x equals a, b, c, d, e, all divided by 3. And I'd like you to help me solve for b. Again, instincts. You probably know this without even knowing that you know this, but there's something right away that your brain and your heart together just said, I think I should do this. What do you think maybe it is? You guys are amazing. Right. Like we've done enough of this to know that the fact that that whole right side is one big dang fraction is a problem. So just like we've learned before, let's just stick on some brackets and say, I'm going to multiply both sides by 3. This whole process I gotta get fraction-y kind of stuff out of the way so I can do my thing. So when I multiply by 3 on the right-hand side, these 3s cancel, and then I bring down the next line, which now says A, B, C, D, E. And what does the left side say? 3x. We're just messing with letters today and tomorrow and Wednesday. Messing with letters. If I want to get b by itself, what do I have to do? Divide by a buttload of stuff, right? If I want b, I'm like, b, sit tight. I'm going to get these fools away from you. And the only way I can pry them off, since they're multipliers, is to divide, like I heard over there, by a whole bunch. Let's divide by a, c, d, and e. You want to divide by 4 things at once? Go ahead. It's okay. Got to do it eventually. Do it all at once. And then we do it on both sides, of course. A, C, D, E. Cancel your A's, cancel your C's, your D's, your E's, and you're left with the final answer, which is B equals what? 3x over? Done. Isn't that crazy? Not that hard. The reason that this is easier for you, and I will say, yes, this should be easier than inequalities, but the reason you're finding this as a class to be easy is honestly because of the work you've put in for the first 5 or 6 or 7 weeks. So if you feel like this is easy, pat yourself on the back and just know that that's because you've done a great job to this point. Did somebody just fart? Is that what's going on back there? Somebody rip one. Did you rip one? Nice. The first ever recorded fart acknowledgement on a Mr. Ahern YouTube video. There you go. There you go for the world to hear. I'm not using your name because I don't think I should, but I'm looking right at you there, Sir Gasses a lot. Ulysses S. Toots. Make yourself at home. Actually, I'm surprised we made it to like week 8 or 9 before someone just floated an air biscuit right in the middle of class. Top notch. Good push. K equals 1/3 of xy squared. And the only thing, like if you've been paying attention, you know reasonably the only thing I'm going to ask you to solve for here is x. We're not to the point yet where I would ask you to solve for y because he's exponentiated, right? So we're going to leave him out of this. So again, follow your instincts. You've got them, you've built them. What do you think we ought to multiply by first? 3. Our instincts are still telling us, fraction, you're bad. And I know how to eliminate you from this whole situation. I don't want to work with you in the problem. So I'm going to multiply everything by 3. Now, the fun thing about this, which it's a lie, it's not fun. The interesting thing about this is that when the 3 multiplies over to this right side, it only multiplies there. Because that whole right side is just one big chunk of junk, when we multiply, it hits the fraction and dies. It's gone. Doesn't distribute like you might think that it should. So on the left-hand side, we get what? 3k. So we just get 3k equals, and then on the right side? Y. Good job, xy squared. So what we've done now is we've eliminated the fraction and put ourselves in a position where we don't have to worry about him anymore. To get x by itself, what would we do? That's right. Just going to divide by y squared on both sides. We're going to cancel out the y squareds, and we're going to be left with x equals what? Gorgeous. Like that. Okay, 5 down, 4 to go. We still feel good? Yeah. All right, let's keep, yeah, right? Let's keep on keeping on. Example number 6. I have a totally, again, made up formula. M equals N plus NRG. You guys who play Rocket League and take the game seriously would, of course, recognize the letters NRG, but that's neither here nor there. I am not going to ask you to solve for n. That's going to be a next lesson problem. So just kind of know that the reason solving for n would be hard is you see how he's in 2 different places. That's a big deal. So for today, I'm going to have you solve for g. Again, you walk in here and you think, whoa, this is so, but it's not weird. It's not that hard. It's like, I can do this. Just follow your instincts. Who do you think we ought to move first to get g by himself? This n right here, I can simply pick up and place on the other side. I want to get him out of the way. So to move something like that, I'm going to subtract him from both sides like this. And again, eventually you don't need to show the work like I'm showing. Just like we do with number equations, eventually you just get super comfy with it. And these n's are going to go bye-bye, and I'm left on the left with m minus n equals nRg. What's the next step? Divide by nr. Good job. And just go with the flow here. You got to divide by whatever you don't want there. If you want g by itself, then say r and n. I'm going to get rid of you guys, and I can do it by dividing. Just like this. So the n's and the r's are going to cancel, and we're going to be left with our final answer, which is g. You actually, if you wanted to go a little bit further, there's a partial division problem that you could do. So like, let me address that in just a second. For now, let's leave the answer in its really raw form. It's perfectly fine. But we're going to leave it as m minus n over nr. Now, there's a very interesting question that just got asked, and you might be interested in this answer. It's not something I need you to do right now, or maybe ever, but you could partially divide. You could go this way. I wouldn't even write this down because this might just confuse your notes. But if you divide following that purple arrow, you can say M over NR like that. And then if you divide following the green arrow, do you see how in this green division problem, those ends are going to cancel? Yeah. Do you see that for real? Then you could leave that one as 1 over R. So this would be an acceptable alternative answer. But again, we're not really going to go down that road right now. You don't need to worry about that. Did that answer your question there, Cruiser? Okay. What I have in the large fat purple box at the bottom of the TV is what we should be leaving our answers as right now, just without the vandalism. Which one? Up here? Yeah, these are just straight up unlike terms. Yeah, we can't do anything with those. Yep. Okay. That was a tough one, I thought, maybe, kind of, sort of. This one is, again, another made-up formula. Imagine that. L.
Person.
Oh, what just happened? You guys got to bring that back. That just exploded. That was ridiculous. Come on now. L's are commonly / always written in algebra like this. If you write them like this, then of course they look like ones. And so L's have always and will always look like that. Please do not write your L's any other way. We don't want them to look like ones. And you cannot write it like this. Why not? Because that's an uppercase L, and we need a lowercase cursive L. Got it? So just get used to it. I want to solve for R. What should we do first? Nice job, you guys. We just instinctively know that we first have to displace the whole term. The chunk that we can move out of the way is step 1. So the 3 W's cancel, and we're left now with our next line, which if we bring down the 2R equals, what do we get on the left side? It is what it is. Remember, you cannot combine those. They're not like terms. So just be comfortable with them staying separated like that. What's the last step? Divide by 2. We're just going to stick a division here, stick one big division over here, cancel those ones out, and we're left with our final answer, which is what? Good job. Still good? Two more. Oh, I didn't tell you what I want you to solve for. How would I possibly expect you just to know? Like you should read my mind. Let's solve for y. Yeah, good instincts. Good, good, good. That makes me proud when you're so quick to say stuff like that. That means we're doing something right. Multiply by 4. Don't burden yourself for the rest of this problem by leaving a fraction around. If we multiply by 4, remember from a previous example, we know, of course, on the left side that we just get 4W. But we also know on the right-hand side that when this 4 multiplies across, remember, it only makes physical contact with that term once. The 4 and the 1/4 just go gone. What are we left with? Just like that. And now with that fraction out of the way, if I said solve for x, you'd divide by yz. If I said solve for y, you'd divide by xz. If I said solve for z, you'd divide by xy. You're going to divide by whatever you don't want to be there. And since we're solving for y, what are we going to divide by? xz. Good. Going to cancel out the x, we're going to cancel out the z, and we're going to be left with y equals what? It is what it is. Don't try to press on. Don't try to take it to and just done. Box it up, move on. Last one, guys. C equals 5/4 of mr squared. Again, if you've been paying attention, you know the only thing I would at this point ask you to solve for is m. We won't solve for r. He's got an exponent, and that's for today off limits. You have to use roots to get rid of exponents, and so we're not quite talking about that yet. Good job. Good instincts. Let's just multiply by 4 straight out of the gate. And if we do that, we get 4c equals what? Nice. And then to finish the job, we can divide by more than r squared. Let's divide by the 5, and let's also divide by the r squared. Remember, division can be done like more than one thing can be done at once. If it's all glued together, you can just off whatever you need to. So like in this case, we're going to divide by 5, and we're also going to divide by r squared. You want to divide by 2 things? Do it up. I say, you got to get rid of it all eventually. You might as well do it all at once. Cancel out your 5s, cancel out your r squareds, and you're left with the answer, which is what? Done. Got it? So I'm going to start the conversion of this video so that it can be made into an MP4 that goes on YouTube. But in the meantime, I'll publish what I have. Your assignment can be found. So give me just about 20 seconds and I'll get that page published so you can get it up. You need separate paper. Step 1, copy the problems. Step 2, solve them out. Okay.